It's time to take things to the next level. You've learned the fundamentals of Vue. You should be able to build almost any type of application you can imagine. There's more under the hood, but everything necessary has been covered. Throughout this course, we've been dealing with the core of Vue. Things like routing or state management are not a part of it. Technically, you could create that type of functionality on your own. That's not fun because it means you would have to maintain additional code along with your application's code. Luckily, there are libraries available that provide these features when building large applications. In order to cover these issues in depth, I'm taking off the training wheels. There are certain parts of the application we'll breeze through to focus more on the relevant topic at hand. At this point, you should be comfortable with things like components, directives, and expressions. Here is the application we're going to build. It's going to be a music app. The user will be able to play songs uploaded by other artists. They'll even have the option of registering for an account. Users who are logged in will be able to upload songs. The app may not look like much, but I wouldn't underestimate it if I were you. It's going to require a lot of work to make something like this. In this section, we're going to create the project, explore the files, install Tailwind, and learn a little about state management. I hope you're ready. Once you are, I'll see you in the next lecture. In this lecture, we are going to begin developing the first major project for this course. As always, we need to create a new project with the Create Vue package. If you haven't already, I highly recommend working in a directory dedicated to Vue-related projects. Pause the video if you need to. I'm already in a directory I'd like to create a project in. Next, open the command line. Let's run the following command: npm init vue at latest. The package is going to ask us a series of questions. Unlike previous projects, we're not going to fly by the questions. This project is going to have a few dependencies. Rather than configuring these dependencies as we go along, let's allow the Create Vue package to perform that step for us. Firstly, we're going to give our project a name. Let's call it Music. Next, we are going to be asked for TypeScript support. For this course, TypeScript won't be necessary. Let's select No. Afterward, the package will ask if you would like JSX support. If you have a background in React, you may be familiar with JSX. If not, that's fine. JSX is an alternative syntax for writing templates. In my opinion, there are not many differences between Vue's templating system and JSX. React developers may be more comfortable with JSX. For this project, the regular templating system is fine as is. Let's select No. Up next, the package will ask about the Vue router package. This package will allow our application to change URLs without refreshing the page. Up until now, we've been working under a single URL. However, you may want to split your application into different pages. This package will help us with this behavior. Let's select Yes. The next question will ask for state management support. Applications are built with several components. Data can be contained within a component. In other cases, we may want to share data across several components. Adding state management support will make this process easier. Select Yes. Testing is another important subject that will be covered in this course. Select Yes for Vitest and Cypress. The second to last option is ESLint. We've been avoiding ESLint. However, I think it's time to integrate it into our project for code quality assurance. Select Yes. Lastly, we are going to be asked about Prettier, which is a code formatting tool. We haven't had the chance to talk about Prettier. Prettier is a code formatting tool for front-end development. Take a look at this example. On the left, the console statement is not indented. Prettier can fix formatting issues like this example. On the right, it'll properly indent the line of code for us. We can add consistent formatting to our projects with Prettier. Hold on a moment. Doesn't ESLint perform the same action? Sort of. ESLint focuses on code quality. Look at this example. The bar variable is unused. This is not a formatting issue, but a code quality issue. Unused variables are a waste of space. ESLint can help us catch these types of issues. ESLint does overlap with Prettier. It offers code formatting checks as well. However, they're not as comprehensive as Prettier. Both tools are great. Unfortunately, the overlapping can cause problems and inconsistencies. The Vue community is aware of these conflicts. Don't worry, by using the Create Vue package, these differences will be settled. Let's select Yes. After a few moments, the project will be ready. I'm going to point my editor to this project. You should do the same. Next, let's install the dependencies with the npm install command. After the dependencies have been installed, let's start the project with the npm run dev command. Lastly, view the app in the browser. Awesome! We've successfully installed the project. In the following lecture, let's review the files generated by the package. In this lecture, we are going to review the files generated by the Create Vue package. Most of the files should be familiar to us. Since we selected a few tools during installation, there will be new files in our project. Let's focus on the new files. First, we're going to focus on the files in the root directory. The first file is called eslint.rc.csj. This file contains the configuration settings for ESLint. Inside the exported object, there are a few settings being added. The first setting is called root. It's completely acceptable for subdirectories to have different rules. You can create a configuration file from within a directory. ESLint will apply the rules from the inner directory instead of the configuration file in the root directory. We can specify a root configuration file by setting this property to true. Up next, we have an array called extends. Configuring the rules for ESLint can be tedious. There are dozens of rules. Our file would become very large. To avoid large files, we can apply rules from other configuration files. In this array, we are applying rules from 3 files. The first file is called Vue Essential. There are rules for checking the code quality of Vue components. Next, there's the ESLint recommended rules. These rules are the recommended rules from the ESLint package. Lastly, there's the Prettier rules. As we discussed before, Prettier may conflict with the rules from ESLint. To avoid conflicts, this file configures ESLint not to clash with Prettier. For most projects, the configuration settings from these files will be more than suitable. Let's move on to the last property. It's called overrides. Sometimes, we may not want to apply the same rules to all files. We can use special rules for specific files by adding this array. In this array, each object can represent a set of files. In this example, a special set of rules are being applied to Cypress test files. Overall, that does it for the ESLint configuration file. Before moving on to the next file, check out the resource section of this lecture for a link to a style guide. The style guide lists recommended guidelines for formatting and writing code. I want to emphasize the word recommended. Most of these guidelines are optional. Vue has 4 categories of rules. They are the essential, strongly recommended, recommended, and use with caution categories. Rules in the essential category are considered highly important. We must follow these rules. Otherwise, we may encounter errors in our application. You should always follow them as they are considered standard practice. The other categories contain optional rules. The last category is called Use with Caution. The rules in the Use with Caution category are rules that are for special edge cases. They're not something you should regularly use unless you need to. Throughout this course, I'm going to try my best to follow the rules specified by Vue. At times, I may deviate from these rules to better explain concepts. One example is that it's recommended not to perform log statements in our code. However, we may need to log values for debugging purposes. Feel free to adhere to these rules as you wish. ESLint has been configured to follow most of these rules. Head back to the editor. Let's move on to the next file. The cypress.config.js file contains the settings for the Cypress tool. Cypress is a tool for performing testing on an application. Testing is a topic covered in this course. For now, we're going to ignore this file until we talk about testing. There may be errors in this file. You can safely ignore them. They will not impact our application. Moving on, let's check out the package file. Inside this file, we're going to find an extensive list of dependencies. We'll explore them as we progress through the course. Let's shift our focus to the scripts object. We don't have the usual list of commands. The create view package will supply us with additional commands. 3 commands are related to tests. Once again, these commands will be reviewed during the testing section of this course. You can safely ignore them. The last command is for linting our project. In an upcoming lecture, we are going to automate linting. It'll be easier to automate this process as opposed to running a command. Overall, these are the major changes in the root directory. Let's start looking at the folders. The first folder is called VS Code. This directory may be available for some of you. If it is, this folder will contain settings for Visual Studio Code. You may get warnings from the editor. If you don't want to constantly receive warnings, you can safely delete this directory. I'm going to quickly do so. The public directory is mostly the same as before. We have the favicon file, nothing else to it. The most significant change is in the source directory. Unlike before, 3 directories have been created, called Views, Stores, and Router. We'll be exploring these directories throughout the project. Don't worry about them. We'll soon become comfortable with everything. Within the Components directory, a new directory was created called Tests. It's another directory for writing tests. Tests are a topic we'll cover in a separate section. That sums up everything. In the next lecture, let's start configuring our editors to format our code. In this lecture, we are going to prepare our editors. We'll be writing a lot of code. We're bound to make mistakes with formatting our code. The project was installed with ESLint and Prettier. However, we must run our code through these tools with the command line. It's not an ideal setup. Ideally, these tools should format our code as we write it. Luckily, this behavior can be achieved with a few tweaks to our editors. If you're using Visual Studio Code, you'll be able to follow along with me. Otherwise, you may need to look up how to achieve this behavior with the editor of your choice. The first step is to install the extensions for these tools. Under the Extension tab, you can install the ESLint extension from a user called Microsoft. As for Prettier, the name of the user is called Prettier. Both extensions should be installed and enabled for our project. After installing these extensions, let's update our editor's settings. On the menu, navigate to File, Preferences, Settings. In the search bar, search for a setting called Format on Save. The first setting should be a checkbox. Enable this feature. By enabling this feature, Visual Studio Code will format your files after saving them. Next, search for a setting called Default Formatter. Visual Studio Code has a custom formatter for JavaScript files. However, we're not interested in its formatting tool. Prettier will fulfill all our formatting needs. We can change the formatter by modifying this setting. Change the default formatter to Prettier. This option will only be available for editors with the Prettier extension installed. We've successfully configured Prettier, but not ESLint. Linting can be automated too. Unfortunately, it's not easy to enable ESLint through the UI. At the top right corner, there's an option for viewing the settings with JSON. Click on it. The settings.json file will open in our editor. Behind the scenes, The UI modifies this file for us. If we look at the bottom of the file, the formatting options have been added to the object. If we were to remove these properties, the UI would be reflected with those changes. In my opinion, modifying settings through the UI is simpler than modifying the JSON file. It reduces the likelihood of a typo. Automating ESLint is not configurable through the UI. We must directly edit this file to enable ESLint on saves. In my file, I've already added a few settings. You do not need to copy these settings. Most of these are a personal preference for my projects. At the bottom of the file, add an object called editor.codeActionsOnSave. This object can contain a list of actions that can be performed after a user saves a file. We can instruct Visual Studio Code to perform actions from formatting to building projects. For our purposes, let's run ESLint. Add a property called source.fixAll.ESLint with a value of true. The action we've added will force ESLint to fix issues with our code. As long as the extension is installed in our editor, this action should work. Let's try testing our code. In our project, open the app.view component. I'm going to add spacing inside the header tag from the template. As I do so, a yellow line will appear below the spacing. This error is emitted from ESLint. It does not like the formatting of our tags. If I were to save the file, the spacing issues would go away. Isn't that great? We don't have to run commands anymore. ESLint and Pinia are cooperating to format our code. This feature keeps our code consistent. In the next lecture, let's begin working on the music project. It's time to start working on the app. Whenever you're building an app, it can be daunting to decide on where to begin. We can move on to the next step, which is to add the HTML and CSS. In this lecture, we're going to take a static HTML template and add it to our project. In the resource section of this lecture, I provide a zip file with everything you'll need. It's the HTML, CSS, and JavaScript that make our template functional. This template was built with Tailwind. If you're not familiar with Tailwind, that's fine. Tailwind is a CSS framework for designing and building sites. It provides a set of classes that makes it easier to present content. The code in the zip file I'm providing you does not have any Vue-related code. I will walk you through every step to convert it into a Vue app. Keep in mind that this is not an HTML and CSS course. You are fully expected to know both languages. Once you've downloaded the zip file, keep it in hand. Next, inside the project, create a directory called template. This directory isn't a special directory related to Vue or the CLI. We're creating it to store the contents of the zip file. I'm going to drag and drop the files from the zip file into this directory. We're adding the template files for reference. This directory is only temporary. You will want to delete it once you've completed the project. With the template at our disposal, let's add it to the Vue application. Inside the source directory, we're going to focus solely on the app component. The components directory will have a few components. We're not going to need them. Let's delete these components. Do not delete the tests directory. This directory will be necessary for the future. In the app component, we're given a basic setup. We're going to start fresh. Completely delete the script block. Next, empty the template block. Lastly, delete the style block. We're left with a bare bones component. That's fine because we'll want to add in the HTML from our template. Let's begin the process of moving the HTML from the static template into the app component. Inside the template directory, we have numerous HTML files. Don't be alarmed. Every template uses the same markup and stylings. We won't have to copy every file. That would be counterproductive. Instead, we only have to focus on a few sections. Usually, we'll want to start with the home page. Then we would work our way down. At least that's the process I usually go through and the process I recommend you go through. The home page can be found inside the index.html file. This file consists of a few sections. I'm going to minimize some of the sections. We want to be able to view the overall structure of the file. I want to review some of this code to understand better what we're trying to build. There's a lot of code, but I've taken the liberty of adding some comments before each section. Be sure to look out for them whenever grabbing the HTML from the templates. They'll make searching for sections easier. The first section is the head section. It's pretty standard. I want you to focus on the style sheets being included. I'm loading the style sheets for the Tailwind framework. Tailwind is a popular framework for rapidly building modern sites. Below it, I'm loading in a font called Roboto. If you want to use a different font family, then by all means, do so. Up next, I'm loading an icon set called Font Awesome. While not necessary, icons can make an app look aesthetically pleasing. The icons are used for the audio player. Lastly, I'm loading in a custom style sheet I created for additional styles that aren't covered by Tailwind. This file mainly contains the stylings for the player and the colors of the site. If you want to customize how the website appears, then this is the file you will want to modify. We won't be editing any of the CSS, as it's fine just the way it is. None of the stylings being provided are related to Vue. It's completely plain CSS. The next section is the header. This section is where the navigation menu will exist. It'll contain the links to other pages of the site. There's even a search form. The search form is not functional. We'll make it functional in a future lecture with Vue. Afterward, we have a section called Introduction. The purpose of the Introduction section is to give a brief overview of what the page is about. Not all pages have this section. It even comes with a simple scroll animation. You can preview the home page if you're curious about what it looks like. This section is unnecessary, but it'll give us the opportunity to practice writing components. The next section is the main content section. Every page will have this section. It's the section we'll see often throughout this course. The HTML for this section will vary depending on the template you're viewing. Moving right along, we have the player section. This section is the audio player the user can use to play or pause a song. It'll display information about the song. It's a basic audio player. You won't find many features that most modern players have, such as a loop, forward, or backward button. I decided not to add those features because adding them in would distract away from Vue. I want to keep it simple. The next section we have is the Authentication Modal section. This section will hold the login and registration forms. We'll be spending a lot of time on both forms. It'll be the main focus of this and the next few sections. This will allow us to learn about authentication and form validation. There isn't JavaScript attached to the template. The template is completely made up of HTML and CSS. We'll be writing the JavaScript code for making it functional. Alright, that's a basic overview of things. Let's start adding in the HTML to the app component. Inside the index static template, we're going to copy everything from the header section to the authentication modal section. Search for the comment that says header or the nav tag to find the header section. Copy everything down to the end of the authentication section. Switch over to the app component. We'll replace the entire contents of the template block. Obviously, this won't work, but it's a start. Let's verify everything works in the browser. If you haven't already, start the server. It should always be running. Nothing will appear on the page. To understand why, open the console panel from the developer tools. A couple of messages should appear in the console. The message we're interested in is the error related to the home component. This component is utilizing components from the components directory, which we deleted earlier. To fix this issue, this component should be updated. Head back to the editor. In the source/views directory, open the home component. Let's remove all code from this file. It's perfectly fine to have an empty component file. View will not complain. Let's refresh the page in the browser. It's an absolute mess. That's because we haven't loaded the CSS yet. That's what we'll tackle in the next lecture. In this lecture, we're going to talk about Tailwind. It's the new kid on the block. In the past year, Tailwind's user base has grown exponentially. There's a good reason for it. Tailwind makes developing sites so much easier and faster. So what is Tailwind? Tailwind is a CSS framework. It's similar to other frameworks like Bootstrap and Bulma. It stands out from the crowd because of the approach it takes with CSS. Let's talk about how Bootstrap approaches CSS. Bootstrap comes with classes for building UI elements. For example, let's say we wanted to use the card component. This code snippet shows how a card component can be created with Bootstrap. We need to create some div tags and slap some classes on them. Pretty simple, right? The biggest criticism of Bootstrap is how similar a lot of sites look. It's because Bootstrap takes care of defining a predefined set of components. These components are ready to go out of the box. Customizing them is completely optional. In some cases, you may want to change the appearance of some Bootstrap's element. For example, let's say we want the color of the title to be red. We can select the card title element to apply the changes. This works, but it's going to affect other card elements with titles. One solution to get around this is by using a better specifier, such as assigning an ID. It works, but it doesn't scale very well. This approach forces us to constantly switch between documents and style sheets. We might also have to rewrite the same CSS. The more UI elements we have, the more CSS we'll have to write. Another challenge is having to memorize what every class does. The classes in Bootstrap describe the UI element. They don't describe what properties are applied to the element. Tailwind resolves this issue by focusing on a different way to write templates. Tailwind does not focus on UI elements. If you were to browse the documentation, you won't encounter many UI elements. Instead, Tailwind focuses on utility classes. What does that exactly mean? Tailwind will define hundreds of classes. Each class will modify one property. For example, there's a class called M4. The M4 class will set the margins of an element to 1 rem. There aren't any other properties under this class. On the other hand, a Bootstrap class can modify multiple properties of an element. For this reason, Tailwind has a larger learning curve. It's a framework that demands solid knowledge of CSS. You won't get far if you don't know much about CSS. Luckily, CSS is a simple language. Tailwind looks difficult to read, but it's not once you understand what each class does. By looking at the classes, you will immediately know what properties are being applied to the element. This saves you time from having to switch over to the style sheet to understand the class. In the resource section of this lecture, I provide a link to the official Tailwind site. On the home page, we'll be shown an example of the type UI elements we can create with this framework. On the right, we'll find what our HTML will look like with Tailwind. Unlike Bootstrap, multiple classes are being applied to the element. Each class will change one property. From this live example, we can see how each class affects the element as they're added in. This leads us to the question, how do we know which class to use? Luckily, Tailwind has some of the best documentation around. Each class is well documented. At the top, we can search for any class. Let's search for the M4 class we looked at earlier. According to the documentation, this class will change the margins of an element. It'll even tell us by how much. We never have to look at the CSS. The documentation will always tell us what property and value a class will have. We're not limited to a single class either. There are multiple classes for changing the margins of an element. We can add margins to one side or axis. Tailwind seems great so far, so what's the catch? Tailwind is much larger than most libraries. Uncompressed, Tailwind is over 300 kilobytes large. Luckily, Tailwind works hand in hand with a library called Purge CSS. In the resource section of this lecture, I provide a link to the Purge CSS library. Purge CSS will scan your HTML for classes that are being used. It'll then remove unused CSS from your style sheets. Purge CSS is commonly used with Tailwind. On average, most Tailwind sites use less than 10 kilobytes. This process is automatically done for us by installing the Tailwind module. As you can see, Tailwind is rising in popularity for a reason. If you're confused by any class we use, you can always consult the documentation. It'll tell you right away what property gets applied to an element. For this course, we're going to be using Tailwind for our music app. In the next lecture, we're going to install Tailwind. In this lecture, we're going to install Tailwind. It's necessary to install Tailwind because the static template uses a lot of the classes defined by Tailwind. If we want the same stylings to appear in the application, we'll need to install it. There are two options for adding Tailwind to a Vue project. The first option is to link the style sheets from the index.html file. This is what we did before. It's a decent solution, but it's not the approach we'll take for this project. Vite should process our CSS files. This project is going to contain a lot of code, which will mean a large file size. We should take every opportunity to optimize our code, including CSS. If we want Vite to process the code, we must do things differently. This is why we will go with the second option. Tailwind can be installed with npm. Best of all, this package has a command for helping us create configuration files for Tailwind. Let's give it a try. In the resource section of this lecture, I provide a link to a guide for installing Tailwind with Vite. We're going to be following these steps for installing Tailwind. Feel free to pause the video and try these steps yourself. Otherwise, let's go through it together. Head back to the editor. In the command line, stop the server. It shouldn't be running during installation. Next, run the following command. npm i -d tailwind css post css auto prefixer. We're installing three packages, which are Tailwind, Post CSS, and Auto Prefixer. All will be necessary for running Tailwind. Behind the scenes, Tailwind uses Post CSS for creating its classes. These packages should have been installed successfully. The next step is to run the following command. npx tailwind css init -p. This command will generate the configuration files for Tailwind and Post CSS. The Post CSS configuration file does not have anything special. Let's focus on the Tailwind file. In our project's root directory, there's a new file called tailwind.config.js. This is the official file for configuring Tailwind. Through this file, we can modify Tailwind's classes with JavaScript. Sounds strange, right? Like I said before, Tailwind uses Post CSS, which is a library for converting CSS into JavaScript. You can think of Tailwind as one large Post CSS plugin. It'll inject a series of classes into our application. We can modify colors, breakpoints, font families, etc. Let's review the configuration settings together. The first option is called Content. During the bundling process, Tailwind will search for its classes from within our project. It'll generate a list of classes used by our app. These classes will be added to the final bundle. What about the other classes from Tailwind? They'll be removed. Before Tailwind can produce a bundle, it needs to know where it can find our files. The content option is an array of files to search for Tailwind classes. By default, it's empty. Let's head back to the installation page. On this page, there's an example from the guide. You can find the example from step 3. Copy the items in the example. Next, head back to the editor. Paste the items into the content array. There are two items in the array. The first item is the index.html file. The second item is a pattern. Tailwind will search for classes in all files in the source directory. If a file has the Vue or JavaScript extension, Tailwind will search through these files. That's all we'll need. Let's keep studying the other options. Afterward, we have the theme option. The theme option is where we can modify the colors, font sizes, and other features of Tailwind. Lastly, we have the plugins option. It's an array of plugins for extending Tailwind. If we leave these options empty, Tailwind will use its default configuration, which is suitable for most projects. Luckily, we will not need to customize Tailwind. The default classes are suitable for our purposes. As you'll soon see, Tailwind can account for almost any situation. There's one more thing I want to point out. You may receive an error from this file. The error stems from the module object. Technically, this is not an error. ESLint is treating this object as an error. It doesn't know what the module object is. There are different ways to avoid this error. I think the simplest solution is to support Node as an environment. Open the ESLint configuration file. At the bottom of the object, add an object called environment. Next, add the node property with a value of true. The environment object will allow us to support different environments. Currently, ESLint assumes that our app is running in the browser. This is primarily true. However, we have a few files that run in Node. To add support for Node environments, we can set the node property to true. You may need to restart the editor or close the file for these changes to take effect. Great! The error from ESLint has gone away. We're almost at the finish line. The final step is to load Tailwind's classes into our CSS files. Open the base.css file from the source/assets directory. Initially, Vue will create this file for creating base styles. It'll be pre-filled with CSS code. Let's completely empty the file. Next, add three directives called base, components, and utilities with the @tailwind directive. These directives are created by Tailwind. They'll inject Tailwind's classes into our project. Tailwind classes aren't automatically injected into our project. We need to tell it where to load its styles. These directives will perform that action. There's one final step. The CSS file must be imported. Open the main.js file. We haven't had the opportunity to review this file. In the future, I promise we'll talk about this file. For now, the main objective is to load our project's CSS. Below the import statements, import the base.css file. Just like that, we have installed Tailwind. It took a while, but it was well worth the effort. Tailwind is an extremely powerful CSS framework. Most of the template styles depend on this framework. In the next lecture, we're going to get some practice with Tailwind. In this lecture, we're going to get some practice with Tailwind. Here's what our site looks like. It's partially broken. We're going to be fixing this soon. We'll start by applying some classes to the body tag. There are two things I want to change. They're the font family and background color of the document. In another tab, I have the static version of the template. In the static version, the font family is set to Roboto. The background color is light gray. We should apply these changes to our template. Let's start with the color of the background. We have two options at our disposal. We could select the body tag, add the background color property, and set the color. Alternatively, we could choose a color from Tailwind. Head on over to the official Tailwind site. At the top, we can search for the property we want to modify. Since we're trying to change the background color, let's search for the background color property. We'll be taken to a page with a list of classes for changing the background color of an element. This table will tell us the name of the class, the property it affects, and the value it uses. There's even a preview of the color to the right. As you can see, there are dozens of colors. Personally, I like BG Gray 100. Let's copy it. In our editor, let's open the index.html file. The index.html file is where the body tag is located. On the body tag, we're going to add the BG Gray 100 class. It's perfectly acceptable to modify the index.html file. In fact, the Tailwind configuration file will search through the contents of this file for Tailwind classes. We're allowed to use Tailwind classes outside of Vue components. Let's refresh the page to see what we get. The background color has changed. Tailwind is pretty simple to use. We search for the property you want to change, choose a class, and apply it to our HTML. No need to write CSS. If you use Tailwind long enough, you'll quickly become familiar with the classes. Let's tackle the next issue. I want to change the font family of the template. Let's head on over to the Tailwind documentation. This time, we're going to search for the font family property. Tailwind will provide us with 3 classes for changing the font family of the element. The name of the font family we want to apply is called Roboto. If we look at the font sans property, we'll find the Roboto font family listed as a value. It's possible a font family is not listed under Tailwind's classes. If that's the case, you can modify Tailwind to include your font family. On the sidebar, click on the Customizing link. Tailwind will provide instructions for how to include a value not listed in its default configuration. According to the documentation, if we want to add a new font family, we need to modify the Tailwind configuration file. Luckily for us, we won't need to modify the configuration. Let's go back to our editors. On the body tag, add the Font Sans class. This class will apply the Roboto font family to our document. However, it will not load the font family itself. We still need to handle that step ourselves. We'll talk about loading assets in the next lecture. For now, we'll leave it at this. I have a challenge for you. We're creating a music application. At the bottom of every page there is an audio player. This audio player is going to need space at the end of the document so that it doesn't overlap with other elements if the browser is scrolled to the bottom of the page. We should add padding. Here's the challenge. Search for a class to add padding to the bottom of the document. After you find a class, apply it to the body tag. The padding space should be 6 rem. Good luck and pause the video. Welcome back. If you were able to solve this challenge, that's great. If not, that's fine too. We'll tackle it together. At the moment, I'm on the documentation for adding padding to an element. There are hundreds of padding classes. We can add padding to all sides of an element, or we can add padding to an axis. We can even add padding to one side. The class we're looking to apply is called PB24. This class will add padding to the bottom of an element. The value is 6 rem. Let's copy it. Next, we'll add it to the body tag in our editor. Great, we're finished. We've only taken care of the CSS. Our template will need images and fonts. In the next lecture, we're going to start loading the other assets for our template. In this lecture, we're going to load the images and fonts from our template. Let's open the template directory for a moment. We have a directory called Assets. This directory contains the custom CSS and images I've created for this course. We're going to load these assets in our project. We'll start with the CSS. Inside the CSS folder, copy the main.css file. Inside the source/assets directory, paste in this file. Next, we'll switch over to the main file to import the CSS file from the custom theme. After importing Tailwind, the path to the file is ./assets/main.css. We're importing the CSS file so that it gets processed by Vite. I created some styles that weren't covered by Tailwind, which is why we're including this file. Most of the styles have to do with the audio player on the page. Let's move on to the images. The images can be found under the image directory. Unlike our CSS files, we don't want them to be processed by Vite. Instead, they should be copied over to the bundle generated by Vite. Here's what we'll do. We'll copy the images over to the public directory. Files placed in the public directory are copied over. They are not completely processed by Vite when we ship the app to production. We're going to make a copy of the assets directory. Next, open the public directory and paste the directory we copied earlier. Once copied, delete the CSS directory in the public directory. It doesn't make sense to continue storing the CSS files in the public directory since they're being stored in the source directory. There are two ways to store files. The source directory can store asset files. If you store asset files in this directory, Vite will process them. If you want your files to be copied over without going through other third-party libraries like PostCSS and Sass, you should place them inside the public directory. Alright, let's give the application a test. Refresh the page. The application is starting to look like the static template. This is exactly what we wanted. If you don't have what I have, then try restarting the server. The last files we'll need to load are the fonts and icons. Let's go back to the editor. Open the index.html file inside the template directory. Go up to the head section of the document. We'll find links to the Roboto font and Font Awesome icon set. We're going to copy these over to the index file. The fonts come from an external source. We don't need to install a module or copy files. We can use a CDN to link them. Let's check out the page one more time. We'll see the icons displaying correctly, and the font should have slightly changed. Let's recap what we've learned. You can load assets by either importing them directly or linking them in the public directory. Either solution is valid. Any files placed in the public directory are copied over in the final bundle. If you place files inside the source directory, they'll be processed by Vite before they're shipped with the bundle. In the next lecture, we'll begin adding state management to the application. We've got the template design loading in like we want it to. The next step is to make the app functional. But the question is, where do we start? There are so many areas to cover. I always prefer to start with the user system. Most applications, regardless of their use, rely on a user system to work. You can't upload a song unless you know who's uploading it. It depends on the needs of your app. For this example, I think it would be a good starting point. In order to have users, we need to be able to store and manage users. We'll need to have a way to authenticate or register them. Authentication and registration is a good starting point. We'll begin with the user system. Before we begin coding the logic, we first need to understand something called state. The word state is a word that's thrown around a lot in the world of JavaScript. But what exactly does it mean? State refers to the data in the application. This can be data retrieved from a database or API. Data like a blog post, product, or media content. You can use the state to store application data too. There are certain types of data you wouldn't normally store in a database. However, they are still necessary for your app to function correctly. For example, a simple dropdown. If a user clicks on a dropdown button, then the contents of that dropdown should be shown. If they click away from that dropdown, then the content should be hidden. This is the type of data you would have to keep track of. Another example would be keeping track of the page the user is currently on. Are they on the home page or contact page? Depending on the URL, you would display different content. Vue provides one way of storing data by adding the data function to a component. While not wrong, it's considered good practice to have one single source of truth. All of this is considered the state of the application. When you hear the word state, it's another way of saying data. It's data that is carefully kept track of while the application is live on a user's browser. If the user is on the home page, then you can call this the home state. If they're logging in, then you can call this the authentication state. It's used to describe what is currently happening in the application. So don't think of state as the data from the database. It's also the data that keeps track of the little things. Throughout this course, we've been using the data property as a way to keep track of things. The data property can be considered a way to store local state. It's data that only one component needs. However, what if we need to share data across multiple components? We need a way to have global state. Global state is when data is shared across multiple components. We have the option of passing down data to other components using props. To send data back to the parent component, you could use a callback function or emit an event. In this example, let's say I had data that was used in child components B and C. Child component C is capable of updating the data. To perform updates on data, we first have to pass down a callback function to child component A and then to C. Child component C can use the callback function to update the data inside the parent component. Lastly, the updated data would be sent to component B. This is the usual flow of data. It's what we've been doing up until now. For a small to a medium-sized application, this works fine. It's a bit annoying to have to pass down everything, but it's certainly doable and manageable. For larger applications, this process of managing global state can become quite tedious very quickly. Imagine if you had 10 layers of components in your application. That means you would have to pass down a callback function 10 times. That isn't very fun. Luckily, Vue allows you to create your own library to manage state on a global level. We won't be going down that route. It's not necessary to do so. Instead, there are already libraries out there that will do this for us. The most popular solution is called Pinia. Pinia is a library for storing data in a central location. You won't have to pass it down from component to component. The state is directly accessible to all components. It doesn't matter how deeply nested your components are. The data can be retrieved or updated. Any changes to the data are reflected in all components. This means it's no longer necessary to pass down data through several children components. Data is handled in one centralized location. Pinia is maintained by the core developers of Vue. You don't have to worry about compatibility issues. This is the library we'll be using for the rest of this course. There's one important point I want to stress. Centralized state is completely optional even if you have it installed. Sometimes you'll have data that will be used in a single component. If you don't plan on passing it down onto other components, you don't need to store it inside the centralized state. Components can still have their own set of data. That's important to understand. You don't want to clutter your state. In this lecture, we're going to review the configuration for the Pinia library in our project. Generally, the first step is to install the package. Luckily, we can skip this step. The Create Vue package installed this package for us. Just in case, you may need to install this package manually. You can run the npm install Pinia command. After installing this package, we must register it as a plugin. Let's stop for a moment and talk about plugins. Plugins are precisely what they sound like. Vue applications can be extended with additional features. You will most likely download third-party libraries to assist you with developing your application. Vue provides a way for other libraries to extend it by providing a plugin API. Plugins can do almost anything. They can add directives, register components, and even provide another API. There are 2 steps to installing a plugin in our project. First, we need to import it. Second, we need to register it. Every plugin must be registered before the Vue instance is created. Otherwise, we might not have access to every feature a plugin provides. Let's open the main.js file. The file scaffolded by Vue is different from before. In between the create app and mount functions, there's additional code. Registering plugins must be performed before mounting the instance. The use method allows us to register a plugin. From there, it's the responsibility of the plugin to extend Vue. Registering a plugin is as simple as passing an object to the use function. In this case, two plugins are being registered called router and store. We're going to ignore the router object. It'll be discussed in another lecture. Let's put our focus on the create Pinia function. This function will return an object compatible with Vue's plugin API. The question is, what is Pinia doing? Behind the scenes, Pinia is registering a plugin with the Vue developer tools. The developer tools are completely extendable. The Pinia package will add a new tool for interacting with the state. If you want help with debugging, you should always register the plugin. Let's check out the plugin. Switch over to the browser. Open the Vue developer tools. Under the Inspector section, we can switch to a different tool. As you can see, Pinia is listed as an option. We can select this option to view the data from our application. At the moment, it's going to be empty. We haven't taken the time to register state with our application. Let's head back to our editors. Inside the source directory, there's a folder called stores. Before proceeding, let's understand why it's being called stores. When learning state management, the terminology is half the battle. The word store is short for storage. We can think of stores as warehouses. A warehouse can store various items. We may store food, furniture, or common household items. It's common for warehouses to be subdivided into specific sections. Food can be put in one section while furniture can be put in another section. Otherwise, you're going to be running all over the place searching for items. This same idea applies to state management. We can think of our data being put into a warehouse. We may have different storages for different types of data. For example, you may have a store for users and a store for blog posts. In our project, Vue recommends defining your stores inside this directory. It's not mandatory, but recommended. For the rest of this course, we're going to adhere to this practice. Inside this folder, there's a file called counter.js. Let's open it. Inside this file, a function called defineStore is imported from the Pinia package. This function will create a special type of object. The object created by this function will have its data tracked. Pinia is meant to be used globally, which can make things tricky. Multiple components can change the data. It's important to keep track of those changes, determine which change should be applied, and what to send to other components. Pinia can handle this sort of task easily. Anytime a change occurs in your state, every component will be notified of the update. It'll make sure every component is in sync with the state. Since changes are tracked, you will have an easier time debugging your application. This is why we have to call this method. It creates a special object for keeping track of state. The object is exported from our script. Before the object is created, we're passing in 3 additional objects called state, getters, and actions. Each property will be explored as the course progresses. That's it. We've successfully introduced state management into our project. We can begin to use it. For this course, we're not going to need the counter store. This example is to demonstrate how a store can be created. In future lectures, we're going to create store files from scratch. Let's delete this file. Once you've deleted the file, let's start creating custom stores. In the next set of lectures, we'll start writing some code. I'll see you there. In this lecture, we're going to split our application into smaller pieces. At the top of the template, there's a link called Login Register. The ultimate goal of this section is to make a modal appear if the Login Register link is clicked. Before we can handle toggling the modal, we'll need to organize our project. Switch over to our editor. Currently, we have one active component, which is the app component. In the template block, we have the entire app inside of it. It's not necessary to house everything in one component because the state is available on a global level. Let's start moving things into their own components for better management. We'll start with the header. Inside the components directory, create a file called appheader.view. Next, add the template block. Switching back to the app component, search for the header section. It'll have a comment that says header above it. I've minimized the element so I wouldn't have to scroll. We're going to cut the nav tag and its entire contents. After you've grabbed the content, switch back to the header component and paste the contents into the template block. The header component is ready. The next step is to register it. We're going to register it locally. Site headers are generally used once. It's not something we'll need available for every component in our app. We won't register it globally. We'll register it in the app component. Create the script block in the app component if it isn't already there. We'll give it the name of app. Then import the header component. We'll call it app header. We're calling it app header because there's already an HTML tag called header. We don't want to have naming conflicts with tags that already exist. An easy trick to prevent naming conflicts from happening is by prefixing your components with a short phrase like app. Next, we'll add the components object to the app component. We'll register the app header component. This is ES6 syntax. This is the same as typing app header, app header. It's a nice shorthand way of doing things. Before we proceed, I want you to check out the style guide link in the resource section of this lecture. I've shown you this page before. I'm linking to a specific function that states component names should be multi-worded. This rule aims to help make sure your component names don't conflict with the names of existing HTML elements. It's a rule we're going to follow throughout the rest of this project. Let's go back to the editor. The last step is to use the component in the template. Scrolling back up in the component file, we'll place the app header component where we previously removed it. Let's preview the application. If you haven't already, start the server. If everything worked, then you will see the page displaying normally. Just to make sure, open the View Developer Tools. Search for the app header component. It will be listed under the app component. Our component is appearing in the list. It has been successfully imported. Let's work on moving the authentication modal. Back inside the components directory, we'll create a file called auth.view. Then, scaffold the file with the template and script blocks. We'll assign the name property in the exported object to auth. Next, go over to the app component file. Scroll to the bottom of the template block. There will be a div tag with the ID of auth modal. It will have a comment above it saying authentication modal. Cut the entire element from the template. Subsequently, we'll paste it into the auth component's template block. The component is ready. Let's register it. Back inside the app component's script block, we'll import the auth component as app-auth. After importing it, we'll register it. The last step is to add the component in the location we removed it. We'll load it at the bottom of the app components template. We've separated two sections of the app into separate components. There are more sections, but we'll get to them later. We want to focus on the elements that make up the authentication. We're finished with splitting the application into smaller pieces. In the next few lectures, we'll start adding the logic for toggling the modal. In this lecture, we're going to start working with the state to accomplish our goal of toggling the modal. We've already taken care of breaking the template into components. This breakdown reduced clutter in our application. The next step is to toggle the modal. Here's how we're going to approach this. We'll need to store a value that will either be true or false. The modal's visible appearance will depend on that value. This means that we'll have to keep track of it. We'll need a way to toggle the value. We can store the value in a component as a data property, but I believe storing it in the state is a better approach. It'll allow for other components to toggle the value. Pinia was created for situations like this. It can contain data that'll be available to all components. Any updates to the data are reflected in all components. This centralized state makes it ideal for holding the flag value of the modal. First, we'll create the value. In the stores directory, create a file called modal.js. At the top of the file, import the defineStore function from the Pinia package. The defineStore function will help us create a new store. We can think of the store as an object that'll track the data stored inside it. The store must be exported from the file. Otherwise, our components will not have access to the data. Export the defineStore function from the default namespace. This function has two arguments. The first argument is an ID for the store. It's completely normal to have multiple stores. Technically, you can create a single store for an entire application. However, it's considered good practice to split your state into multiple stores for easier manageability. The ID will allow us to identify the store. Let's set the ID to modal. Next, pass in an object. In this object, we can add various properties for interacting with our state. Before we define functions, let's add the state property. The value for this property will be an arrow function that returns an object. Inside the state object, create a property called isOpen with an initial value of false. The state object is where we can add our data. Any data that you want globally available to other components should be defined here. The data is ready. Let's learn how to access it from a component. Open the header component file in your editor. Inside the header component, we have a navigation menu. It's an unordered list with Tailwind classes. Above the menu, there's a comment that says Primary Navigation. We're going to focus our attention on the link that says Log and Register. If the user clicks this link, we'll want to display the modal. The modal's appearance will depend on the value of the isOpen state property. If it's true, the modal will be visible. If it's false, it'll be hidden. Essentially, clicking this link should toggle the value. We'll attach an event listener to the anchor element. We're going to listen for the click event with the prevent modifier. We're going to set the value to toggle auth modal. We won't pass anything to the function. The function doesn't exist, so we'll define it next. Below in the script block, set the name to header and create the methods object. If the script block does not exist, add it in. Inside the methods object, we'll define the toggle auth modal function. This function will be responsible for toggling the Boolean value we created in the state. The question is, how do we access the state? Pinia has a function for merging the store into our component. At the top of the script block, import a function called mapStores from the Pinia package. This function will merge the store into the component, thus giving us access to the state. Before running this function, we're going to need the store. Import the store with the following name, useModalStore. It's common practice to follow a specific naming convention for your stores. The name must always be prefixed with the word use and affixed with the word store. This naming convention helps developers understand that we're using the store in the component. It's optional but recommended. We're going to follow this practice for the rest of the course. In the components options, add the computed object. In this object, call the map stores function with the spread operator. This function accepts the store. Let's pass in the use modal store object. Back in the toggle auth modal function, the store is now accessible through the this.modal store object. The map stores function will create an object with the name of the ID. In our case, the ID of the store was set to modal. You can refer to the modal.js file for the name of the ID. The word store gets appended to the name. Therefore, if we had a store called user, the object would be called userStore. Inside the function, we'll want to set the current value to its opposite. This is a simple trick to toggle Boolean values. To verify if the value gets toggled, we're going to log the value afterward. Let's check if everything is working. Opening the browser, we'll open the developer tools and switch to the console panel. Then, I'll click the Log and Register link. After doing so numerous times, we can see the value is changing. We have a way to update the state. We are allowed to access the state through the store object. We can even change the value if we'd like. Great! We've successfully created our first state property. In the next lecture, let's begin applying this state to the modal. In this lecture, I want to show you an alternative solution for mapping our store to the component. Currently, I'm viewing the header component. You do not need to follow along. It's perfectly fine to watch. Previously, we imported the map stores function to help us access the state from the store. We haven't had the chance to talk about this yet, but stores can have functions. We're not limited to defining data. Functions can be added to the store to interact with the state. By using the map stores function, everything from the store will be accessible. In this example, we're not using functions. Only the data is being accessed. In this case, it may not be necessary to map the entire store. It's possible to only map the state. From the import statement, I'm going to add two functions called mapState and mapWritable_state. Both functions will map the state to a component. There's one difference between both functions. The mapState function will treat the state as read-only. Updating the state is not allowed. If you were to browse the documentation, this process is known as mutation. Developers will use the words update and mutate interchangeably. They mean the same thing. As for the mapWritable_state function, this function will allow us to update the state. You may be wondering, why would we want to use the mapState function over the writable function? In some cases, you may want to take extra steps from preventing state from being updated in a specific component. Not all components will need to update the state. Just read from it. Let's try using this function. In the computed property, we can add the mapWritable_state function with the spread operator. This function has two arguments. The first argument is the store. Let's pass in the modal store. The second argument is an array of state properties to grab the store. We do not need to grab all properties. Let's add the isOpen property. The arguments for the mapState and mapWritable_state functions are the same. You can swap one with the other. After mapping the state, the toggle auth modal function will need to be updated. The state will not be accessible through the modal store object. Instead, they'll be accessible as properties. We can shorten this code to this.isOpen like so. This produces the same behavior as before. As you can see, mapping the state can make our code readable. You do not need to map the entire store. For this course, the original solution was fine. I'm going to undo the changes I made in this lecture. In the next lecture, let's keep talking about state management. In the previous lecture, we learned about mutations. They're a way to change a state property inside the store. Just like you can create mutations, you can create something called getters. Getters are exactly what they sound like. They allow you to access a state property from the store. Using a getter is optional. We can access the state property directly through the store object. The store object is injected into every component. Here's an example of how you would access the state. This is one way of grabbing a state property from the store. Pinia offers another solution for retrieving a state property called getters. The main benefit of using a getter is the support for caching. It can intelligently update itself when the state changes. We've learned that the computed properties are one way to cache a value. One solution might be to write a computed property for every state property we'd like to use in a given component. That would work, but then we would face duplication issues. We'd have to define the same computed properties in every component. That's where getters come in. You can think of getters as computed properties for your store. One of the main benefits of a getter is that they're accessible to all components. Define a getter once, use it everywhere. Getters are also smart. They will only update if the state changes. This can help with the performance of an application. Let's prepare our application for using a getter in the next lecture. The objective of this lecture is to create a getter for the isOpen state property. We'll need to create one because the modal will use it to decide whether it should be visible. The next step is to make it appear on the page. By default, it's hidden from view. We're going to toggle Tailwind classes on the modal. Currently, the hidden class is on the root element of the auth component. This class should be added if the modal should be invisible. We'll remove it if the login register link is clicked. By default, we'll add the hidden class to the modal. We're going to use the isOpen state property to toggle the class. This is where getters come into play. Getters are a way to retrieve a state properties value. Let's switch over to the store file and create our first getter. Inside the store object, add another object called getters. The getters object is where we must define getter functions. Inside this object, we're going to create a function called hidden class. Alright, inside this function, we have to return a value. Getter functions are required to return a value. For this example, our getter function should return the hidden class. If the isOpen property is truthy, the class should be applied to our elements. Otherwise, an empty string will be returned. Every getter function is provided the state, which we can accept as a parameter. After accepting the state, return the following value: not state dot isOpen question mark hidden colon empty string. The getter function is ready. Getter functions are exposed to the components in our application. The next step is to use the getter function inside the authentication component. We'll switch over to it. Getter functions should be added as computed properties. Similar to the store, we can map getter functions into a component's computed properties. First, let's import the store. In the script block, import the modal store with the following name: use modal store. Next, import the map state function from the Pinia package. The map state function can map getter functions. It's not exclusive to state properties. Let's try using it. In the components options, add the computed object. Within the object, call the map state function with the spread operator. Pass in the modal store. Lastly, add an array. The name of the getter function was called hidden class. That's it. We've exposed the getter function to our component. You may be wondering, couldn't we have defined the hidden class computed property directly in the component? That's definitely possible and allowed. By outsourcing the logic to the store, the function can be mapped to any component. Otherwise, the function would have been only available in the auth component. We'll want to hook the computed property to the modal. Scroll up to the template block. On the div element with the ID of modal, we're going to bind a class attribute separate from the first one. The class attributes will be merged. We're going to set the condition to the following: hidden class. Time to check if this works. Switch to the browser. If I were to click on the login button, the modal would appear. Fantastic. We've successfully opened the modal. Sadly, we can't close it. We'll handle this problem in the next lecture. In this lecture, we're going to close the modal. It'll be a simple and quick fix. Unlike before, we're not going to map the store. Since we learned how to map the state, I think mapping the state will suffice. For demonstration purposes, I want to show you different ways of tackling the same problem. At the end of the day, it's up to you. Let's open the authentication component file. Scroll to the script block. Let's import the map writable state function from the Pinia package. Inside the computed object, let's call this function with the spread operator. Pass in the useModalStore object. Lastly, pass in an array. In this array, add the isOpenState property. Great, our state property is ready. The goal is to set this property to false. By doing so, the modal will close. Scroll to the template. Search for a comment that says Modal Close button. Below this comment, we'll find a div tag with the class modal close. This element will contain the close button for the modal. We're going to listen for the click event. Inside the event, set the isOpen property to false. Save your changes and refresh the page. Let's test the modal by opening and closing it. Voila! Previously, we defined a method to toggle the property. However, it's perfectly fine to toggle the value from the event. In addition, we mapped the state instead of the store. Pinia is very flexible. It provides various options for interacting with the state. In the next lecture, we'll look at further improvements we can make. In this lecture, we're going to add an alias for our state properties. Aliases can be a great way to rename state properties for a component with dozens of properties and methods. There are two problems you may come across when working with large components. First, you may have properties with conflicting names. Secondly, the names from the store may not be descriptive enough for a component. For example, let's look at the property's name from the modal store. It's called isOpen. This name isn't very descriptive. What if we had a dropdown that's toggleable? Does this property affect the modal or dropdown? We wouldn't know by looking at the property. For these reasons, you can try renaming the property. However, renaming a state property from the store may not always be practical. If your state property is being used across several components, those components would need to be updated. Rather than going on a wild goose chase, you can rename a state property from within a component by using an alias. Let's look at an example. In the auth component, we should rename the isOpen state property. Previously, we mapped the state into the component by using the map writable state function. The second argument accepts an array of state properties to map. Let's replace this argument with an object. Inside this object, the property name will represent the name of the state property. Let's rename the isOpen property to modal visibility. Next, the value should reference the name of the state property to rename. Let's set this property to isOpen. By using an alias, we do not need to modify the store, nor do we need to update components outside of the auth component. Only the auth component is affected by the renaming. We're not finished yet. Scroll to the Close button. On this button, change the expression to use the modal visibility alias. We can continue using the state property as we did before. Pinia is smart enough to update the appropriate state property from the store. Let's visit the browser one last time to check if everything is functioning. Open and close the modal. The modal will toggle its appearance without a problem. Technically, we don't have a property called modal visibility in our state. Regardless, we can still use an alias. This alias can be useful in case you have conflicting names in your application or you would like to shorten things a bit. For this course, we won't need to use them. Switching back to the editor, let's continue moving forward. The modal is completely toggleable. The last step is to work on the tabs in the modal. At the moment, both forms are appearing. We should toggle the visibility of both forms based on the tabs. We'll tackle this step in the next lecture. In this lecture, we're going to make the tabs functional in the modal. The application is slowly starting to come together. The modal is functional. The next step is to add logic to the content inside the modal. We have two forms, which are the login and registration forms. Both forms shouldn't be appearing at the same time. Above the forms, there are two buttons. We're going to make them functional by allowing the user to switch between forms. This functionality is known as tabs. Let's get started. Open the authentication component file in your editor. The first step is to tackle the current state of the tab. Which form should we show the user? We'll set the login form as the default form. We need to keep track of which form to show. We have two options at our disposal. We can store this information in the store, or we can store it as component data. We're going to store it as component data. This information doesn't need to be made available on a global level. Whenever you're creating data, you should ask yourself if the data needs to be available globally. If it does, storing it in the store is the way to go. Otherwise, storing it as component data will suffice. You never want to clutter your store with unnecessary data. Scroll down to the script block. We're going to define the data method. Inside the object, we're going to add a property called tab. Its value will be the following: login. If the value is login, we'll show the login form. If the value is register, we'll show the registration form. Let's use this data to toggle the visibility of the forms. In the template, search for a comment that says tabs. Below this comment are the links for the tabs. We're going to add click event listeners to both anchor elements with the prevent modifier. For the login link, we're going to set the tab property to login. Next, for the register link, we're going to set the tab property to register. By updating the property, we should be able to toggle the tabs. After changing the property, the last thing we need to do is change the appearance of the tabs. On the login link, there are three classes called Hover Text White, and BG Blue 600. These classes will change the background color of the link to blue and text color to white. They should only be applied if the tab is active. We're going to bind another class attribute. The value for this attribute will be an object. We're going to cut the three classes I mentioned earlier as a property to this object. For the condition, we will check if the tab property is equal to login. These classes will get applied if the user is viewing the login form. We're going to add another set of classes if they're viewing the registration form. The class we'll toggle is called Hover Text Blue 600. This class will change the text color of an element to blue if it's being hovered over. We're adding this class because we want the user to know they can interact with an element. Adding a hover effect is a great way to show that an element can be interacted with. The condition for this class will be the following: tab equals 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 register. That takes care of the login tab. Let's work on the register tab. It's going to be similar to before. Let's copy the class attribute we binded. We'll paste it over to the register tab link. In the conditionals, we're going to flip them. This modification will give us the opposite of what we had, which is what we're looking for. There's one last step. We need to toggle the visibility of the forms. Below the unordered list element, there are two form elements. The first form is the login form. The other form is the registration form. We're going to be using conditional directives to toggle their appearance. On the first form, we're going to add the vShow directive. The condition will be the following: tab equals 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 login. Lastly, another vShow directive should be added to the second form. The condition will be the following: tab equals 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 register. We're finished. Save your changes and refresh the page. If we open the modal, the login form appears. The registration form is gone. The links above should have the proper classes applied to them. Since the login form is displaying, the login link should have a background color of blue. If we click on the register link, the login form disappears while the register form appears. The tabs also change. Great! After verifying that it does work, we can move on to the next step, which is to add form validation. We'll cover that in the next section.